Welcome everyone to the November 3rd OMR Architecture Meeting. Today we have a topic to discuss that was proposed by Erwin. So we'll be talking about an idea for unit testing the compiler API. So I'll turn it over to Erwin. Please take us through it.
Hi. So I brought this issue up actually in OpenJ9, but then because there is overlap and any implementation there, I think would also depend on an OMR piece. They're also just bring it up here just to, in that it might be more general. Before I get into it, I wanted to put a mild disclaimer / sort of preamble that the things that I put up in the code and the prototype that I put up is not the end all. I think the reason I went down it was just sort of because I had an idea of how one might do unit testing, and I just wanted to, because I know I've heard and I put it in the OpenJ9 issue, which I can put in the chat actually, just so people can read it, even though it's not part of OMR. Is it better now? The sound, James? Or is it still too far away? Okay. So as I put in the issue, the general idea sort of was inspired a bit by languages like Rust and Go, where in the language itself you can have a test. I'm not sure about Go, but at least in Rust there's a test module where it's essentially like your main program is linked into another program that's just test, and then you call these minor routines and stuff. In part of why I started over there at OpenJ9 was because at least in OMR it doesn't quite this thing could work in OMR, but OMR has a test compiler. It's a lot easier to just take the compiler component and make another thing and link it. Whereas in OpenJ9 it's much harder because of there's so much dependence on the VM, the portlib, and a whole bunch of other libraries that if you were to just open the JIT-DLL, you're not going to get anything in a state that I think would be very easy to work with, because so many things assume, memory is just available and the front end is just available and so on and so forth. So what I did was in sort of keeping a little bit with the test module idea and a mild inspiration by the debug extension, I sort of had the JVM just sleep, or run a Java program that just sleeps, and I had the JIT not compile anything. So now the JVM is just stalling around, but everything's initialized. And then I just had a hack where I was able to use the test infrastructure to just create a comp object and a whole bunch of environment and memory and all that stuff that we need, and then invoke a test where it just calls a method inside of one of the optimizations. And then because that method nicely had an if condition that exited early, I was like, oh, let me just see if I can call this and not get into the rest of the code, because I'm pretty sure if I did, it would probably segfault. And I didn't add signal handler support and stuff because I wasn't trying to do a full robust implementation. I just wanted to show that actually we can do a unit test. And so that's what I did. If you want me to, I can open the code and we can look at it a bit more, but the actual implementation, I think, is less important. More so what I wanted to discuss was the fact that it's not actually that hard to do unit testing, and it is possible. But this is just a prototype to sort of bring up discussion for things we could try out. I'm by no means saying that this is the best way of doing it, but the fact that I was able to do it in 3 hours or so or less, and in an optimizer that I have no idea what's going on. If you look at how I had to create the actual unit test case, there's VP constraints that make no sense, but I just needed them to exist so that I could test one specific thing. My whole claim is that people who know this code will actually do it better and write unit tests that are actually sane and sensible.
So the test compiler and even Trill within OMR is really sort of it starts with you producing IL that that you can inject into the JIT or the compiler, and it'll find its way through the system and produce some kind of a result. And presumably along that path, it's going to be testing the thing that you wanted to. The sense that I got from what I saw, your little prototype there, was that you're trying to specifically target a function within the compiler itself to test its behavior.
Yeah, and it's contract essentially.
Yeah.
Which is what you can do in languages like Rust and Go.
So the challenge that I thought, though, and I don't know how Rust or Go handled this, and maybe if you know, maybe. So a lot of times you have to provide a lot of context around, like you have to provide an environment in which that function can be tested. You can't just pass in one thing.
Yeah.
I think in your case you just passed in the compilation object or something.
No, I had to create IO, and I had to create the optimization object as well. Because the method belongs to the loop word.
Yeah, you created a node, load node without a simref.
Yeah.
But you did create one and passed in the const as well.
Yeah. I mean, I guess the thing where I'm getting at is that you may have to, for anything more than just a simple method, you may have to create a lot of context in order for it to even do anything.
So I think that's one of the things that I was talking to BJ about this before, and he had an idea as well that I'll let him discuss. But the thing here is that it's, as the code stands, our code is not very, what's the word? It's not easy to write unit tests in our code right now, because our code is, there'll be big methods, they do multiple things, and like you said, you need a lot of context. So one way of adding unit tests is to slowly start breaking them up into smaller methods that are easier, and over time, as a general, like cleanup effort that you do slowly. When you get into a particular part of the code, you're like, I could refactor this, and when I refactor this, if it's not too complicated, I can run a unit test for it, so that. And this would be in any unit test scenario, because the thing you're talking about is a general problem of you need a lot of context. But if you can find a method where you can find a minimal set of context, like the simple thing that I did there, where it's testing just that first condition, I didn't need much. I just needed 2 nodes and a couple of things.
One question, since you said that the scope is wider here, right? The discussion is a general one about unit testing as a whole. One place I could start is, do you want to have all of the JIT be unit testable, and therefore you want to move towards that by refactoring routines, as you were saying earlier? Some are ready for unit testing, others aren't. Maybe refactoring would get that part of the code ready. Do you want that to be the thrust of this work, or do you want to identify certain parts of the JIT that can be more readily unit tested? And I'll give you 3 examples, actually. There's evaluators, there's simplifier handlers, there's VP handlers. Sure, I'm not going to claim that they're perfect for unit testing, but they're closer to being unit testable than most other pieces of code. And so if you wanted to unit test evaluators across N platforms and N VP handlers and N simplifiers, you could easily spend a fair amount of time going down that road without hitting quite the amount of resistance you're likely to hit in other directions. So what is the thrust here? Is it to do more of that sort of unit testing? Is that the bigger goal? Or is it to, no, that's, well, while we can do that easily, we're really after the bigger goal, which is to make everything more unit testable?
My whole thing is to make, in general, everything. I'm not saying that's something that it can be done easily, but like that's sort of the whole point. I mean, I think the fact that evaluators and others are more amenable to this stuff is good. There's going to be some amount of overlap between, I think, what Ben did before, where when he cleaned up the power evaluators, he had written a whole bunch of tests in OMR.
Yeah.
And some of that, there's going to be some amount of overlap, which is why this mechanism in general may be, like, while it's closer to what, Go and Rust do, which is a test module, and that, like, this is not a module, you're running the whole thing again. Again, it may not be the right way to go about it, but the goal for me anyways is to have it so that eventually we get to a point where when people write new stuff, if a unit test can be written, it should be easy to write a unit test.
So that's the ultimate goal.
Yeah.
It's more like not to harvest any short-term opportunities
No,
to
no,
do unit
this is like
testing necessarily.
like this is sort of in keeping with like technical debt reduction in general, which is just
Okay.
like a cultural shift towards like.
Okay.
And the reason I got here was because I recently had to write tests for in OpenJ9. I added a new PR where we can merge the compiler option, and then Jonas was like, "Please write some tests." So I had to go look at the test, and it actually wasn't that hard. I mean, it was a little tedious in terms of how the OpenJ9 testing framework is, but it wasn't that difficult. And I'm like, oh, well, I mean, anyone could do this. We just don't because no one enforces it. And that's just a cultural thing that we can change. And this is just one idea towards, hey, if it's easy, maybe we can find ways of making it easier for people to write tests in general.
Yeah, no, that does make the goal clear.
You had mentioned it before too once in another PR, and I was like, oh, it's too hard, but like realistically, I don't think it can work, right? But like, I'm not blaming you, but like, you're not forcing me, and I'm just like, but like, it's not an excuse. It's something that I have to get better at it as well, right? So this is just like me sort of thinking about ways to, in general, make it better.
I think the kind.
I was just going to say, to be clear, I'm fully in support of people investing more in being able to better unit test the compiler. I completely agree that that would be a much better place to be in if it was easier to do that. I always feel uncomfortable putting a restriction on someone saying you have to write unit tests when there is such little support for doing that in the code base.
That's exactly why I'm like, I'm trying to,
we should do better. Right?
If we get it to a point where once we put in a bunch of work, I'm not expecting people to do the work because you're right, it's unfair. That's why like this is there for like, even if it's me only doing it, I'm fine. It'll slowly happen, and then it's the thing of like you could point and say no, this exists. But you're right. As it stands right now, how do you force someone?
There's, I think, at least two big obstacles, and I think you touched on one of them. The code, the routines themselves are not granular enough. But there is another problem which I was getting into in my comments in the issue, but also with you, is the data structures have a certain nature to them, right? They sort of expand out, if you know what I mean, right? Like, so an instruction has a pointer to a node, an instruction may have a pointer to a code gen, I'm not sure. But if it does, then a code gen has a pointer to a compilation, which then means you have a pointer to everything. So that sort of creep in terms of the data structures makes it harder to just create a little thing here that you can just pass into this routine and run it through, right? Like, my worry for your sort of approach was that, right? That you created a node, you passed it in. Okay, that maybe node you can't go to treetop, but actually from some nodes you can go to treetop. But let's say you passed in a treetop, and then you said, treetop get block. Well, there's no block around here. I spent all this time creating this tree. So then you say, okay, let me go create a block. But then the block could say, give me the previous block. And so you know what I mean? Like, there's this creep that.
So yeah, if you start walking down that path, you end up at some place like JIT Builder.
Yeah.
In a way, because that's kind of how I got there too. Right?
Yeah.
Was via the IL injection thing, and then the IL builder thing, and then JIT Builder, and JIT Builder 2. There's another comment that I wanted to make too, just kind of a response to your the pointing out that there is a test compiler and the JBold stuff that we have, the Trill stuff, that we have at in OMR. I would say, so I hadn't seen your pull request until 10 minutes ago.
I mean, it's not
so forgive me if I've drawn an incorrect assumption from what I read in the code. But it does look to me like what you've done in OpenJ9 is essentially what the test compiler is supposed to be. It's infrastructure to be able to load a compiler without necessarily being connected to all of the other stuff and having to go through all of the other startup and initialization and configuration that's associated with bringing a compiler up in a specific runtime, right? Like you're doing it in the context of Java, you created the raw allocator, like you kind of went through the steps that we do when we're initializing the JIT so that all the main kind of pieces are available to it. And then you hack up a compilation object, you hack up some IL, and you feed it into some function with the hope that you've created enough of a shill that function can be tested. I think that's completely in line with what the test compiler was designed to do. It's just that I only ever used it to build IL and inject it directly in as a function or a method, right? But there's nothing to stop you from starting with the test compiler and aborting that and saying, all right, like don't generate IL, start running a test that just calls directly into some part of the compiler.
I'm aware of the test compiler in OMR. It's just that the reason I never looked at that stuff is because, again, like I said, the OpenJNet has so much dependence on where the memory is coming from, and so on and so forth. And you may need to make a front-end call, in which case you need to have.
Yeah, my main point was that philosophically, you're not doing something philosophically in opposition or in conflict with what the test compiler and the stuff that was done with control is doing. I think it might be interesting to start. So I like your idea of focusing on starting looking at the simplifier handlers, the value propagation handlers, and the RDP handlers, and the codegen evaluators, because they're already very focused on looking at a very specific pattern of IL, which might make it easier to build up a set of builders, I'll call them, that can help you construct little bits of IL outside of the rest of the context, so that you get enough context there. Like you need a treetop, there's a way to get a node with a treetop. If you don't need a treetop, there's a way to build a node without a treetop. Like that, those kinds of, like, you step back a little bit and say, don't make me make all the calls to create a treetop, to create a node, to create a symbol reference, to create an alpha. I want one of these things that has, a node and I need a node with a sim ref that has this kind of sim. Like there are ways to kind of pull that API up a bit so that it's a little easier to mock something up, and then then there's a question how you test the output.
Well, it is overlapping a little bit with what Trill was trying to do, where you sort of describe the tree and then you inject it. At least, like right now, you're injecting it and compiling it all the way through. But if you could inject it directly into VP or directly into the back end,
and maybe that's what we need to do with Trill. Right?
I think that
Trill is the mechanism for doing that. Right? That provides a more descriptive way of.
Well, otherwise, it would be unfair. I think too much of a burden to put on an average developer to go and do that intricate stitching together, or whatever needs to be stitched together. If they could just write IL as text, have something go and process it and create the data structures out of it, and then maybe this is a good point to say that one other twist that I had that I talked to Irvin about, which is you don't want to put the burden on people to write 40 lines of IL for every test, right? Sometimes a test is only different from another one with a minor sort of delta. So you could write one trill sequence, let's say, and it gets processed and some data structure gets created, or the treetops, everything gets created properly. And then if you had the ability to say, go change this part of that sequence and just specify the delta, right? Like instead of having an I load here, can you just put in an L load here kind of thing?
Trill already supports that. Like you can build a trill from like a print. I think I've seen that before. So, like somewhere where you can kind of make this type of something. Maybe it's that you produce a string and then you can parse that string to create trill. I think I've seen.
Yeah, there are trill tests that work that way.
Right.
They printf and then they parse the result of the printf, and then the what's going into printf is whatever your test is parameterized on.
I see. So it's composed. So it's like composed, almost like extendable in some way. Okay.
But I think from my point of view, Mark's point about how do you test the output is crucial. I think, I don't know, there are some of these more testable, like little bits of things, like a single evaluator or simplifier handler or something, but I think that this idea that, well, what we need is to just be able to write down some IL and say, okay, well, what does something do with this IL? And I think that's really what we need. And especially I like that a lot better than trying to slice up the data structures so that they don't have the relationships that the entire compiler expects. But basically, if we can get because there's this talk of like, okay, well, we make up a fake compilation and then we don't really compile and we do this and we do that, but most of the things that I envision wanting to test, what seems to be a unit to me is, like an optimization pass, for example. And we should be able to say, okay, here's some IL, give it to the optimization pass, right? And compile it and run it, right? Because if we can't do that, like that's the functionality of our system, right? That's what we want to
So
test.
are you saying that's,
Optimization that doesn't generate executable code.
are you saying that that's surely a stepping stone along the way to making routines, sort of exercising routines or unit testing routines? Let's bite off something that's a little more modular in a sense, right? Like an
I'm
optimization is a
only half
self-contained
saying
thing.
that.
Sorry, go ahead.
I'm only half saying that. I think that there may be some things that are more granular than, say, an opt pass that that can be tested, at a more granular level, like, say, your example of the simplifier handler, right? But interestingly, you don't need to be able to test at a more granular level to test the simplifier handler. You just, write some IL that just has, just that node in it, basically, and then run simplifier on it. Testing the VP handler, that seems like it would want something actually a bit more targeted. And then I'm sure that there are other bits of things that that could be more amenable to testing, or that could be made to be more amenable to testing in a more granular fashion. But I think that a lot of the things that are sort of in the middle of the pass, that are happening, are not really extricable from it in a lot of cases, right? Like I'm doing some loop version or fixes right now, and these things don't make sense without each other. The things that it's doing, they're interrelated, and it's important that they're interrelated. But what I do know is that, for the most part, a pass is something that stands on its own.
Much more so than, yeah, individual routines.
My one point to that would be that if the pass has many branches, we want to be able to, like, we want to be able to test ideally the leads. But if it's too many branches, then we need to find a better way of sort of figuring out what are those paths that are always going to run versus actually this may only run under certain circumstances or whatever, right? Like we have to find the points in the branching in the tree where you can hit as many hit as many leads as you can. It's the only concern with sort of an opt pass by itself. But other than that, like that would be the, like when I was thinking about this stuff, an optimization just seemed a little too lofty of a goal for what I was trying to think about. Like it just seemed like it's technically doable.
Well, it's harder in one way, but also easier in another, right? So it's harder in the way that if you really did think of it as how many ifs or how many conditions are there, well, hundreds is probably the answer. So you'll lose your mind trying to unit test all combinations of these ifs. But,
right, like what subset of the data structures do I need to pass in, and let me cook up exactly that subset, or like, but no, if you just actually create IL and run the optimization and then say generate code.
Yeah. So it's easier in that sense, right? You can just run the optimization, so say generate code.
But I think a large part of the reason why we're not there with OpenJ9 yet is just that there's a bunch of stuff that we do in J9 that we don't know how to generate from Trill, or we don't know how to generate, hook up Trill to specify that, say this method should just magically have this IL or something.
Yeah, after
those
the
two
initial,
things.
after the initial implementation of Trill, I know that Leo was working on, for example, how do you reconstruct a node with node flags, or how do you create a symbol reference for the purpose of creating a symbol reference table? And I think it's possible to do, but it was, it needed a lot of thinking and polish to get everything just right. But even if you were to do something like that, I think it was an issue that you would raise, BJ, in the comments to Irvin's thing about something like, the symbol reference or a symbol, for example, needs a constant pool address and a constant pool index, but we don't have either of those. So there's paths through the code that we're trying to test that are going to fail because you need to create some kind of an artificial version of some of these things that would naturally be there in the wild, but we just don't have it in our little incubator. So we need to almost find all these different artificial things that we need to create for all these different structures we need to create and have some answer for all of those.
Right, because we need to be able to specify things like, oh, this node can't overflow, and then things like, oh, the constant pool entry for, this is the constant pool entry for this field or whatever. And then we would have to make sure that such a constant pool entry exists in the class that is supposed to contain it, and then go looking for it or something.
Yeah,
Some of that actually can be done, because at least in this mechanism where you're running Java code, you can have the Java code there that has these constant pool entries where you're expected to be. And then what you're actually compiling is none of the methods, but you're in the class, so you have access to so on and so forth, right? So the constant pool stuff can be done, and
There's a piece of Java that's associated with the test that can provide those parts of the infrastructure.
Yeah, and I think I mentioned that, because right now it just sleeps, but you could compile a bunch of stuff too, and then
even run code. Yeah, I mean, I don't want this to sound discouraging, because I really do want to encourage this kind of work to proceed. But one of the biggest challenges that I see with it is the longer term maintainability of the infrastructure, and the fact that when you're unit testing, you're by definition kind of testing very low level details, and as Devin pointed out, there's like any number of these little details that you might need to kind of surface in the test, and those all become aspects of brittleness between the tests that you've got and the infrastructure, the code. Like, people are continuing to work on the code and changing it, which means the set of details that you might depend on in the unit test are changing over time. Any significant refactoring of code can also come with a bunch of tests that got busted because you no longer have the, I refactored this code and it now expects this symbol reference to have a symbol in it, whereas it didn't before. And now all the tests that go through that path now need to also have a symbol in place, right? And if the mechanisms that we use to write unit tests expose that detail in the test, then now you've got millions of tests potentially where you have to go and add the symbol, right? So I think this is a significant problem that we need to think about while we're building out this infrastructure. Is how do we do this in a way that we don't end up tying ourselves in knots in a couple of years after, like, if we finally managed to successfully write a whole bunch of tests for the compiler, but now we're handicapped because we can't change those. We can't change the code, or else the tests will all break.
Yeah. So oh, sorry.
No, I was good, Devin.
Okay. I was just going to say, I think that, something like, oh, this symbol reference, is going to be expected to have a symbol now, or whatever, is that, for that kind of thing, I think that's a matter of generating input that is faithful to the way that it, would be in actual usage, right? So, basically every symbol reference also has a symbol, and so we wouldn't try to skip that. Right.
It was an example. I mean, I
right.
can think of raising well-formed IL. I mean, IL changes too, right? you've got a bunch of tests that depend on it, and then some of them need it when, like, it, again.
For sure, for sure. But at least
Oh,
then we
kind of
would
pro,
know
yeah.
that we're changing. You know, I think sometimes maybe what we consider to be valid IL kind of changes behind our backs when we're not paying
Right.
attention.
Actually, the example I gave isn't the worst one. The worst one is we had a node flag, and now you have to go and figure out which tests need to have it set one way and need to have it set another way.
So, I mean,
Right.
I don't want to put in words in devil's mouth, but the thing that I got from what you mentioned was, however we would create that thing in the compiler is how we would do it in the test framework. That way, when the compiler changes, the test framework would also use the same routine.
Yeah, sure, but it can't. You can't capture. It's hard to capture intent for things that don't exist previously. Right. So my example, right? Like there's certain IL where you'll have to generate the flag one way because that's the way the IL looks. Other tests could be generating the IL another way, and it relies on the value being something else. But the test wasn't written to take that into account.
Okay, so and any new flags should there should be nothing that relies on them being clear.
That's easy to say.
Do you have much
If I can
perspective
quickly
of
chime in here.
Hey,
Hello, Leo.
Yeah, hello. Sorry, I had to join a bit late, but
no problem.
I think Mark's point is it's a very good point. And this is actually a problem in general, right, with unit testing, that you have to make sure that when you're changing something that you're not breaking a whole bunch of tests to the point that maintaining the tests is more work than maintaining the actual code. In the context of unit testing specifically, the way one tries to address this is the tests have to be specific. So if you change one thing in the compiler and all of a sudden you have 100 tests failing, the first question I would ask myself is, are those 100 tests really needed, or are they all testing the same thing? If anytime one changes something, though, if anytime one of those tests fails, the other 99 are likely to also fail. That probably means that the tests are redundant. So when thinking about how you implement a framework to test the compiler, part of what needs to go into that design is having a way to make sure that the tests are specific enough that you're not unnecessarily testing the same code paths over and over again.
So that assumes that the things you're testing are small functions that don't have a lot of complexity. Right? If you have a function that's got a lot of complexity in it, then aren't you necessarily going to have to write a bunch of tests that, like, I have to get to this code path somehow, so I have to have a bunch of common stuff between the tests that will get to that code path, and then there's all the code paths downstream of that I want to test those variations.
Data type, different data types, different arithmetic operations like subs and adds.
Right.
Those sorts of things could lead to multiple tests while still fundamentally being driven by, like, they could all break at the same time if you added a flag that applied to arithmetic, int and long arithmetic.
I mean, there might have to be, at the risk of it getting even crazier in terms of scope, but two like styles of unit testing. One is the one that I was sort of philosophically inspired by, which is the contract of an API. And then there's the thing that Devin is talking about, which is test optimization and run the code and make sure that the code is functional. And I think both are probably useful because the contract of the API doesn't mean anything if the code you've generated is garbage and vice versa, right? I think the contract of the API helps you in terms of new functionality that you've kind of forgotten, some implicit assumption. And I think that's where my thing was inspired by, but by no means does it have to be limited to that scope. But
So like, you're testing that you can go through all the paths in the routine without crashing, basically.
I'm testing essentially the leaves of the branches, which is just like specific methods where they're small enough and you can say, I want to test the contract of this thing. The general idea of like you should be able to generate code and run it is like a compiler. It's a test specific to a compiler, which is you better have generated functional code. So
Right.
and that second side of testing is where these redundancies can come up, because, like you said, different data types will generate different code. You need to have, like, they have different semantics. Whereas unit testing in some other programs and other products will not have this problem because they're not also generating code that has to run afterward. They're just running. So it's a bit trickier for us.
There's also, just to expand on what you said too, right? I mean, they're all different forms of testing are going to be valid in different places, right? Like, okay, in the optimizer, which is basically running on top of IL and making IL transformations, it's understandable that at one level you want to be able to unit test what it does to input IL and generate the output IL and what's the code going to do. If you look at some of the runtimey aspects, like that are associated with AOT or with accessing the shared class cache, in some places, there's no IL at all. It's just kind of, I've got these code paths that I want to test, that I detected all of the scenarios properly and did the right thing. That one's actually even harder to figure out that you did the right thing. Like, what's the output of this test? How do I test that the right thing happened? It's even harder in those cases, but in some senses, it's just as important.
I mean, relocation.
It's just as important, maybe even more important in some of those cases.
I mean, relocation would be a quote-unquote easy unit test, because if you say, I want you to pass this value, you better have passed that
value,
yeah.
right?
So,
right.
Yeah, I see what you mean.
As long as you know what it is.
Yeah.
So I'd like to add the other thing that I wanted to say to Mark's point earlier, and now to Leo's point about needing to change too many tests, is that I think that is another reason why in a lot of cases I don't think we necessarily want to test at least optimization passes at a much more granular level than the optimization pass. Because basically inside of there's going to be, there's stuff that we do, right? And if you test that stuff, you can go change that stuff, and then, now maybe, now you have to rewrite those tests or whatnot, right? But if it doesn't affect the behavior of the pass, then changing those tests is not necessarily very worthwhile, depending on how tricky the particular stuff is that maybe it's a very tricky thing, and it's this analysis that you can separate out and la la la. There will be cases for that, but I think that the opt pass granularity, again, at least for optimizer things, is a good way to try to avoid being too coupled to the specific implementation, while also sort of being a good granularity to try to express where we want to sort of over specify in the test, because I think there are cases where functionally we don't want to, or we don't have a requirement that in a certain way that any opt pass does anything. Right? We could just say, well, it just does nothing, and the code works when it comes out, so that that's good. But with respect to that level of functional requirement, we do want to over specify what it's doing. So things like, oh, in a situation like this thing here shouldn't prevent this transformation from happening. We should transform, right? But I think that is a good way to think about or frame deciding which of those things to overspecify in that way.
Yeah, I think it is important to overspecify, because there's accidental ways to get the right answers.
Right, but just not to overspecify too much, right?
Yeah, I don't know if I made my point clear there. Maybe I'll try to reiterate it in a different way. Because what my point was that, yes, it is definitely important that we try to avoid the case where making one change causes a whole bunch of tests to fail, if only because that's in general considered a sign of a low quality test suite. There's two things you can do to avoid that, really, which are closely related. And one is you have to make your tests more specific. The other one is you have to make your code more testable, which I know is a challenge because historically, the OMR compiler has not been architected to be testable. But I guess my point is that that might need to be part of the final solution, is not just thinking about how we're going to test it, but also how we're going to make it more testable.
Yeah,
That seems like one of your fundamental goals when you started the whole discussion.
Yeah, you weren't there for that. One of them was, and this came from talking to VJ, where like it was like a recognition that this is both a framework design thing and also you have to slowly get the code in a place where it's easier.
Yeah,
and also, when I was talking about it back then, but when I was talking back then, we hadn't gotten into what Devin had mentioned and stuff, so my mind was still very much in the unit test of the smallest method we could unit test with the least amount of data structures. But obviously that's not a good way of doing it. It was just where my mind was at that point of the meeting.
Well, I think that could be valuable for certain things.
Yeah.
I don't think that it's, oh, well, every function we write should have, a suite of unit tests for it.
Yeah, you're right. That's also overkill.
But about what Leo was just saying about testability, I think it's a matter of degree, and it depends on where you introduce a bug or what, right? Because like you can have a pretty simple function, say, and you could test, maybe there are 10 cases that are important to test, and maybe they don't even maybe they're not even like particular branches or something, but it's just these cases are important for our understanding of what it's doing. And so you do those those 10 tests, and you can break the thing in a way that breaks all 10 tests, but it doesn't mean that they're redundant necessarily. They're redundant with respect to that particular bug, but they are not redundant with respect to other possible bugs.
Yeah.
Yeah,
And
for
it doesn't
sure.
necessarily mean that it needs to be broken up and made more testable.
Yeah. I mean, for sure, absolutely. You don't take what I said as an absolute that one bug must only trigger one test failure. It's more of an issue when you have like one small change triggering 100 or more test failures. That's usually a sign that there's a broader problem with the test suite. I think if it triggers maybe 10 test failures, 20 test failures, that's more reasonable.
So we phrase that slightly differently and say either there's a problem with the test suite or there's a problem with the thing that you're testing.
Oh, right. Because so we can maybe if we distinguish
I don't mean that
the one small change, like if the one small change is a bad change. Oh, sorry.
No, sorry, I was just trying to clarify. I didn't mean necessarily that, like, the thing that you're testing is bad, i.e. it has a bug, but more that it's not structured properly for being tested.
It's doing too many things at once, and therefore you can't tease out
the behavior with a simple test. Right? That's why many tests. But anyway, sorry, go on, Devin.
There are serious disadvantages to doing far fewer things at once in the compiler, right? So, we want to have like if you had if our simplifier transformations were each separate passes, we would have to run obscene numbers of them, right?
Yep.
It's very important that it does a lot of things at once. You know, versioner now, as well, just as an example, it does some number of versioning transformations that, you know, there's an analysis to determine whether it can do them because they can depend on each other. So you can have a situation where we can't do transformation A or transformation B or transformation C or transformation D on their own. But if we do all of them, it's good. Right? And it's important to get things like that.
Yeah, I
So
think,
I'm not sure that I would characterize doing too much at once purely based
yeah,
on
definitely.
test
I think
suite.
Leo's general point is I think it is that there are good reasons for having a single change break multiple tests, and there are bad reasons for it. And as long as you're closer to the good reason state,
Right.
that should be aspired to.
Yes,
Okay, and I guess
that's a
what I
good way
would
to put it.
what I would uh, just add before the comment from Mark, it was that right, if we distinguish why the change is causing the failures. So when Leo says, oh, if a single change is causing 100 test failures, that's bad. Or you know whatever, you can come up with whatever number you like, 1,000. Just to make it really obvious that it's bad. I think it depends on the it depends on the nature of that change. If it's a bad change, that's a bug. I don't care if it causes 1,000 failures.
Yeah. I guess I was
If it's
more.
a good
Um,
change and we need to change the tests, that's when it matters.
yeah, I guess I wasn't specific about that, but that latter case is the one I had in
Right.
mind
Okay.
specifically.
That makes sense. That makes a lot of sense to me.
Yeah, so there's definitely, I feel merit in what Devin was saying, that if you can test at an optimization level, some things seem more practical, doable. Going back to where you started, like routine at a time, I still think there's value for that in certain places, as we discussed earlier. But the other place where that may have value is even if there are more complex routines, you pass an input that exercises paths in there and emerges out of the other end without crashing.
Yeah,
That is a
because even in an opt path, there may be specific transformations that you just want to make sure happen. They may not be. It may not be something that you want to do in every single case. Like some basic stuff where you're just changing one node to something else or something. It doesn't mean anything big, but maybe if you're, I don't know, taking a loop and hoisting something out, you want to see that thing looks the way. Maybe that's too simple. Someone optimizer might.
yeah, some other transformation. I'm trying to think of what.
You know, for example, even in lower trees, you just have a simple path that says the compressed refs transformation is what we expect it to be. So that if something changes and you know it's known that the treetop is now an LTA, blah blah blah, that looks in the form you want to look for a particular IL. You don't have to try every single version of that thing, but like there's going to be some amount of unit testing that makes sense even in the optimizer, but then in general, you're right. Not like an optimizer itself might just be something where you need to test the entire path. And evaluators, which the reason I even look at an evaluator because sometimes evaluators call other evaluators, and I was like, I don't want to go down this path. But even there's some complexity in that, like
But there is complexity, but it's a different type of complexity than a sort of pick a random method in loop versioner and say, or run you now, right? Its normal contract is to come in without sort of the same paraphernalia surrounding it. It's like, I will take in a node, and yes, I'll need to access the code gen and the compilation for certain things, but chances are I'm not going to have to access the previous treetop. Chances are I'm not going to have to access the previous block.
And you just get an instruction stream and verify that the instructions look what you expect.
So that gives you a degree of flexibility if you can exploit it. Not depending on those things being set up, you don't depend on anything to
there's like the binary encoding maybe, and I think that maybe this is where Ben was doing his work, right? That he was testing the. That sounds like again like it's less likely to be dependent on. Like, why do you need to look at another instruction if you need to binary encode this one, right?
Yeah. I don't know if there's more high levels to discuss, but one thing I want to ask is like going forward, just in terms of having a path towards getting somewhere, should the first step be sort of identifying components in the component? Because clearly it seems like Optimizer has a different philosophy on how to unit test. CodeGen has a different, or even in the CodeGen, like evaluators versus binary encoding might be different, relocation is different, so on and so forth. So I mean, if we could list out the different components and what happens there, but then beyond that, even in terms of going forward, like what is the infrastructure that we want to even go down, right? Like if it's Optimizer, first of all, Trill hasn't even worked with OpenJ9 yet, so that's something that has to think. If we want to use Trill, we got to think about that. So I guess just like I can make a list of like priorities and stuff, but I also wanted to get a sense of like how do we actually tackle this?
Well, I think we haven't really talked about it very much here, but I think we could go through the set of things that you had to do in order to get an OpenJ9 JIT operational to be able to run even the kinds of things that you're looking at. Right? I mean, that's like eventually we need to. So we could look through that list of things and try to identify what are the common set of requirements that we've got across, like the union of the requirements across all those things to say what that infrastructure needs to look at. That's a sort of slowish but more complete way of doing it.
You could also, sorry.
No, go ahead.
So you could also start in one of these more friendly places, right? Like if you can't even get an evaluator to work or a simplifier.
Well, I mean, the reason I'm asking is because in order to even get there, what am I using to test it, right? Like, I don't want to create a hacky thing here and then we change the infra and then, I mean, I guess I can, so the infra as it stands right now is pretty quote unquote clean in that like it's not clean in implementation. It's an array of function pointers, but the theory is that, okay, I'm calling a high level API and it just runs a bunch of tests. So I suppose even if we change the infra later on, changing what infra we want to use.
Did you integrate that with like GTest or something like that?
I'll have to look into that.
It shouldn't be too, like from what I saw anyway, I don't think it would be too difficult to integrate with GTest and then at least give you a framework for.
Is GTest going to have any kind of compiler restrictions, like in terms of does it choose features that we don't support in our compiler?
I don't care.
Okay.
I mean, we use GTest as part of, like Google Test as part of the OMR compiler testing, right? I've been using it from JV2 as well. It's actually quite simple to get up and running and get going, and it doesn't place any restrictions. And plus, this is only a test framework, so as long as it can run on the platforms that we care about in some way, it doesn't have to be part of the binary, so it doesn't have the same. I mean, at some level, you want to test what you're releasing, but on the other hand, given the state of unit testing, some testing on some platform, even if it's not one we ship, is better than.
That's why the thing I even put there was like you could even have these things if stepped out and they run in PR build, for example. So they're not even part of the final binary because why have the code flow? We're never going to run this code. And if the customer hits the problem, why would you tell them to run it then?
And I would say, I mean, the way I would do this, which maybe not everyone will agree with, but I would say your early days here, get something up and running to the point where you can play with it and do some stuff with it and use it to do some stuff, and then just like continue to look back on what you've done and say, is this the right thing to keep going to the next stage of this? Like I've used this to write a few tests. Here are the things I learned. The next set of things I would do are X, Y, and Z. Is it good enough to do X, Y, and Z, or can I already foresee that it's going to fall apart? And that's when you start thinking about how to re-implement.
I agree. I mean, at this point, I think it's too much of a burden to design everything upfront. I think you should test out some of the scenarios and come back here by all means in a short period of time, like a few weeks or a few months, and we can have a better, like I have got my hands dirtier in these ways, and found these were the shortcomings, except I also think there's at least, like the IL is just one side of it, right? Testing parts of the code gen, maybe the IL's gone.
Before I came up with, sorry?
Sorry, go ahead, Leo. What did you?
Oh, I was just saying that I went through 4 iterations of Trill before I came up with the thing that eventually got merged. So absolutely.
You don't hear about IO injector.
And then there are other parts of the JIT that I feel could be unit tested, but we didn't talk about here. I mean, we have to conclude here probably soon anyway, but options is another area, which is a murky area, but feels like one that could be unit tested in certain ways, but obviously none of what we do in IL and CodeGen is likely to apply there. So maybe it's really, there's multiple problems here, and we should also start talking about some of those things that we haven't.
There definitely are, because I don't think we focus very much on what the runtime aspects of the pilot testing, like
That's also harder to test too.
code patching, for example. I mean, well, they've been tested to death, but they can still change sometimes. So,
Well, I mean, especially when you look at OpenGen and with the comp thread stuff, I mean, some of that stuff is very hard to test because you have to kind of build up the framework for it. Which is why I started here, because this just seems quote unquote simple.
No, I'm just sort of adding fuel to that. There's lots of different scenarios to test different mechanisms.
And each one of which may involve a design discussion and a design of its own.
That's the whole reason for it. That I didn't want to start doing, I mean, now that you said try this out, I will. But the reason I didn't go too far is because I didn't want to get down a path where the infrastructure is too narrow and can't be broadened anymore. But I suppose you're saying that there's too much anyway, so you might as well start down that path and see what happens.
I mean, you're going to learn things by iterating, and if you get to a point where you feel too hamstrung to continue, then obviously, we need to sit back and think a little bit harder about it and say, are you just trying to do, you're trying to broaden it beyond what the value of using that testing infrastructure is? Like, are you trying to do too much with it, or is there a way that we could broaden it so that it could encompass more? I think we're too early to be able to even make reasonable choices.
Yeah, the other cautionary thing I would like to say, that just as we were saying, you shouldn't try to design this from the beginning and get it perfect. The other thing you should give yourself some room for is, even if you succeeded wildly and everything went to plan over the next 2 years, there are still going to be substantial parts of the JIT that aren't going to be in the state of being unit tested, and then maybe that's okay, right? Like, maybe if 70% of it is amenable to this sort of testing, and you have 6 designs for separate parts of the code to test out that 70%, that's a splendid move forward, and possibly more. That way, you know what I mean? Like, don't get hung up on a solution just because it won't work in the worst possible routine that we have, right? Like, try to solve what you can with nice, clean designs, and maybe 70% of it. Sorry, go ahead, Darryl.
No, I mean, I would be extremely happy if it was 70%. I would be happy with 30%, to be honest. I mean, it's just the surface area of the code is just so big that I think that, and we're doing almost no unit testing at all. 30% is way ahead of where we are. The only thing that and I don't think there's any sort of competition for this, but just in terms of coming up with a unit test solution, I'd like us to have one unit test solution and not introduce multiple ones, because we have a very good habit of partially designing things and leaving them around. So we have many ways of doing the same thing. So, but I don't think there is really anything like that in OpenGen. In OMR, obviously we have Trill, which I think has value for other things.
I mean,
but
like BJ mentioned, that I think Trill could be used even in this case. If you, like, for example, the builder notion. Like, maybe Trill is the low-level data-driven stuff that you have, and the builder reads it and makes your actual IL. I mean, like, nothing prevents Trill. I guess what I would have to look into is test compiler what it does and also G-test. But I guess one idea would be to just design it in such a way that it's a abstracted away API for get me IL. And then how you implement that could be, in my case right now, it'll be garbage, but then later on it could be Trill or whatever.
Yeah.
So
Yeah, I mean, G-test
I think
gives you an easy way to write tests that get run as part of the process.
I don't have to think about that.
You don't have to think about all that, like, did it pass, did it fail?
Right.
Here, just like you just say it passed or it failed or whatever, and then give it a name and off you go. And all of the sort of control over, it's like, I only want to run this test or whatever, that stuff is all kind of handled for you by G-test, so that's kind of nice from that perspective.
Sorry, Devin, you were saying.
Oh yeah, so just people were saying, oh, I'd be happy with this much % of the things being at least kind of tested and whatnot, and I'm gonna go one further and lower expectations, at least as they're coming from me, and say that I would be very happy if none of it was tested, but next time I am fixing a bug, I can write down some IL and say, okay, there's a check cast in this loop, and and run this pass, and this transformation should have happened, or this transformation should not have happened, or something, and then run the code and I get the right result. If I can do that, that is amazing.
Yeah.
I mean, the facility that's available in Rust, like the thing you were saying was sort of motivating you. I have a suspicion that a lot of that is really intended for brand new development, where you can think about testability as you're writing code, as opposed to a new code base, or an existing, very old code base. How do you adapt
Rust
it?
very much goes through the compiler-driven, class-test-driven development. Like they encourage that. They want you to see the compiler errors and develop, and want you to see the test failures and develop. You're right, but like the fact that if you make it easy to write tests in mainline, it's much easier. Like you can just write a test in mainline and it's good, right? Like, that would be nice if you could not have to remember, oh, gotta write it in this other file. Like you just.
Does anyone have any insight into how LLVM deals with this problem? Curious.
The only things that I've seen are that you have something like an input IL that they have a textual form of the IL. And then I don't even remember how targeted, if it's like they run one pass or whatnot. The ones that I've seen were just in when I was away in another job, and I think those ones were they were Clang ones, so the input wasn't IL, it was C++. But there were special comments in there that said, oh well, we should be able to find this sequence of instructions in the output, and
Okay. That sounds reasonably brittle too.
Yeah, I think the LLVM tool is called Lit. It basically works the way Devin described, is you can feed it input, and I believe it can be either LLVM-IR or source code. A little like what Trill aspired to be once upon a time. But yeah, you can write in comments that are basically just asserts to make sure that whatever the output is satisfies certain properties.
So it's not so much a compile code and run the code to see if the code does the thing that you expect it to do. It's more verify properties of the generated IL, like the transformed IL.
Yeah, that's this tool specifically. There's also a separate individual LLVM front ends typically will keep their own suite as well of just pieces of code that they run through the compiler and then execute and make sure that it executes properly.
Right. Because I mean, as usual, we focus a lot on the. I guess you don't tend to have very complicated unit tests, so maybe it's not as big an issue for unit tests. But obviously, if you're running, if you write a test that then generates code, you want coverage on that, on the paths in that generated code as well. So it's like it's not as simple as just running a test. You have to run a test that makes exercise.
Yeah, that's definitely
right. You gotta test the compiler and test the compiler's output.
Right.
Actually, now when they were mentioning this stuff, because of the way this framework works right now, you could theoretically run code that you generate very easily because you just have an empty function method that you're compiling.
Right.
And if you just call that empty method that actually has code, and then you verify the output, right?
Right. The complexity there then boils down to so controlling the conditions on the input, like conditions that are in the input code that are also in the output code. You can sort of envision it's like, well, I just have to provide different inputs to be able to go down those different paths, and I can, in principle, get 100% code coverage on all of the code paths because I know what the input conditions are. But in JIT code, that's not the case because we inject our own conditions, right? So it's like this thing is resolved, isn't resolved, right? Those kinds of like embedded, there's a bound check, right? There's a this thing's on the heap or it's not on the heap. Like there's all kinds of tests that we inject into the code itself that may or may not be directly under control of the running environment.
I think some of it has to be like binary code verification. It's like I expect this sequence. Some of it is
also brittle, but yes.
No, I know, it's unfortunate, but like, you could, as part of the test framework, if you could say, I'm a generate code for this machine, then if the new machine, you wouldn't have generated some of the new instructions anyways, right? So I think that's fair, that you could make it less brittle that way. But anyways, it was just a side thought that like, I was like, oh, you could actually very easily run code in our case, but.
Yeah, running the code, running it is one thing, but then controlling how to execute is another aspect of the problem.
I mean, maybe that's something
Sorry, what was that, Erwin?
I was going to say that another thing that we could, but I'll open up another issue or something just to talk about the things we talked about, and I'll try and mention some of these caveats, but if you guys can put your other thoughts or whatever I missed, I'll appreciate it.
Okay. I was just wanting to say that I don't think that running the code is very easy. I think that that's where you're going to run into easily the most trouble with something like, say, gtest, which I think wants to take over main, and or if you have when we compile a method, it's going to it's not just the compiler that wants to run in a specific environment, it's the resulting code that also wants to run in a specific environment, and it's a different one, right? It wants to run on a Java stack as part of a Java thread with all kinds of
So I
whatnot.
mean, that's why, like, because of the way the framework's set up right now, the JVM is sleeping, right? You could have Java code that's just sort of sitting there, I don't know, reading a system property or something. And the compiler is done compiling it, updates the system property. Java code goes and calls this empty method that's actually empty in bytecodes, but we said, no, run this, and then it just runs it, right?
Right, or we could give it like a runnable or something, and then we've compiled our implementation of runnable, and then it calls run.
yeah, something like that. But essentially, at least in open, so I know in the context of OMR, I don't know how we would be doing this in general, but in the context of OpenJ9, it's actually not that bad because of the fact that the way I set it up, the JVM is running, and there is a Java thread that's just chilling. So in general, you're right. I don't know what, like in the context of OMR, I don't have a good answer to your problem. In the context of OpenJ9, I have call it a hack or something smart. The line's very funny. But it's a fair point, and I'm not going to remember everything we talked about, but
it's psychology.
Okay. Good.
And just about gtest in OMR, so we can't upgrade to the latest gtest because not all real compilers will work with it. There actually is a bug. So, because we tried this 3 or 4 months ago.
We're still on 1.8.
I think, I can't remember the numbers. I think 10 is the latest one or something, and then 9. I think we work up until 9. But I think so, however, like Mark was saying, even if there may be ways of working around some of these problems, right? So that, because the feature that, it was Brad that wanted to get these features that are gtests to restrict which kinds of tests were being run on certain architectures, which is a feature available in the latest version. I mean, it would be a shame not to have that, for 90% of the platforms, because one, well, yeah, exactly. So we can work around that. So. Okay.
But thank you for, not, for actually, I was expecting it to be like your code's crap. More positive than I thought.
That comes later, that comes later.
We didn't look at your code, so.
Well, that's it.
Yeah. No, not in this
Scanned it for
meeting. I looked at.
less than 10 minutes. I'd say your code was good. I think your ideas are good. Not about
Since
your
you're asking.
No, the code was pretty bad. I'm hoping for the ideas to not be, yeah.
Right, my pattern matcher only works like someone creating a load without a simref. I can spot that quickly.
I was trying to find, like, the minimal set of things I had to do. You didn't mind the VP constraints all being the same?
No. I was okay with egregious other problems, but things that didn't, like, anyway.
All right. Any other discussion on this topic? Or
I guess just one thing I'll bring up, maybe for the sake of my own curiosity. Once upon a time, a few years ago now, I guess, we had actually brought up something, or a few people had come up with the idea that's not, it doesn't sound to be too different from what Erwin was talking about of, in OpenJ9, basically adding some functionality so that you can add, say, an annotation to a method that makes it so that have the annotation take like a string as parameter, that would be some trill code, and have some machinery that makes it so that when you have that annotation, the body of the method would get swapped out for the compiled trill code.
Like in Java code itself, like the test you're running?
Yeah. And so then that would basically give you, make it so that you're already in the Java environment, you already have the full JVM set up. You have the constant pool and all the symbols and symbol references are defined. It's just you're swapping out the body for your own test case. I don't know if that ever got investigated beyond just discussion, but I remember the conversations.
I don't know either, but I do like that idea. I think you could similarly, you could put some annotation that says, say, we got to call this 64 times so that there's iProfiler, or that we got to, run, run just CodeGen on this, or run this pass and then CodeGen, or.
Yep. But from what I remember of the discussions, the big challenge at the time, again, this was all very theoretical back then, so there's likely more big challenges, but the one big challenges we had thought of was making sure that that information, like the constant pool and symbol table and symbol reference tables, making them predictable enough so that if you have to access one of those entries from the trill code, you can reasonably predict or name it, so that things get resolved properly. I'm sure there's ways of making that work.
I think you could probably name it. I don't know about guaranteeing where it would get put in.
Yeah, it was just something to keep in mind that we thought of.
Yeah, I mean, that's a good idea, actually. Do you know if there's an issue for it, or it was just sort of discussed?
I can't remember there being an issue about it, but
I don't
yeah.
think so either. And I only vaguely remember that now that Leo is mentioning it. So I don't know which context in which we were discussing it, but I don't know if I don't think an issue ever got created from that. But
the one,
it's on record now.
The one quote unquote downside is that, like, in the context of OMR, like, that's very Java specific. You have to be something similar for how you would implement this in OMR. But, or do you just, I guess, depend on Trill there? Have the framework take in the Trill code in a different way, I guess, is the only.
I mean, if there's parts of, I mean, even for the other investigation that you're doing, if there's parts of that could be contributed to a common compiler or common infrastructure, then
I mean, I think the infrastructure would be common in that, like, the test, the thing that runs the test fit in OMR as well because you want to test OMR code. The infrastructure builder thingy is OpenJ9. It builds the OpenJ9 specific infra. I guess there would be more environments. They would have to be something similar there. So maybe the environment in OpenJ9 reads the annotations, whereas in OMR it reads a different way. So maybe it doesn't matter actually.
It has to be abstracted in some way.
Yeah.
Okay.
Oh, thanks, Leo. Cool.
Any other final comments?
Thanks, Leo, for weighing in.
Yeah, no problem.
Okay, great. All right, well, we had a good discussion today. Thanks everyone for joining, and we'll meet again in 2 weeks. Everyone, bye.